Chapter 4, Section 5, we look at scattered plots. And scatter plots are simply dotted graphs. So the first example, they ask us to create a scatter plot. Table shows the number of points scored by a high school football game in the first 4 games. And I'm going to have these go up, I'm going to make 4 of them be 10. So 1, 2, 3, 4 is 10. 1, 2, 3, 4 is 20. 1, 2, 3, 4 is 30. 1, 2, 3, 4 is 40. 1, 2, 3, 4 is 50. So in our first game, they got 6 points. In the second game, second game we got 21 points. Third game, they got 46 points. And in the fourth game, they got 34 points. So generally, as they play more games, their score is increasing. Next one, we have some endangered species, and I'm going to make each of these, I'm going to make 2 of them be a year, so that's 1996. And I'm going to go 2 spaces, 97, 2 spaces, 98, 99, 2000, 2001, 2002, and I just did that so that I can space it out a little bit. And then let's have these go up by 5s maybe. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 70, 80, 90. In 1996, 91 species of animals were added to the endangered species list. 97, there were 79. 98, there were 62. 99, there were 11. 2000, there were 39. 2001, there were 10. In 2009, there were 9. I'm sorry, 2002, there were 9. So what happens here, I'm guessing that the endangered species list started in the 90s. And so the first couple years, there were a lot of animals that were endangered. And then as more species got added to the list, they had fewer animals then to add to the list. And your page breaks might be different than mine. You might not need to flip pages now. A correlation shows the relationship between the independent and dependent variable. Shows the relationship between the independent and the dependent variable. A positive correlation, as the independent increases, the dependent increases, generally goes up. Negative, as the independent increases, the dependent decreases, and that goes down. And no correlation, there's simply no relationship. The graphs are just kind of always all over the place. So as average daily temperatures increase, the visitors to the beach increase. That would be positive correlation. And number 4, as the years increase, the number of people in the snowboard competition increase. That would be a positive correlation. Number 5, as the number of empty seats increases, what happens to the students in class? As we get more empty seats, there are less students in class, so that is a negative correlation. Number 6, the number of pets a person owns and the number of books that they read. There is no correlation there. And the monthly rainfall, as rainfall increases, what happens to the depth of water in a reservoir? That would also increase. So that is a positive correlation. 8 and 9 were asked to match the scatter plot to the situation. Relationship between the age of a car and the amount of money spent on repairs. Well, as your car gets older, you generally have more repairs. So this would match up with graph B. As the car gets older, 6th year, they had almost $1,000 worth of repairs. Number 9, the relationship between the number of minutes since a pie has been taken out of the oven and the temperature of the pie. Well, as the pie comes out of the oven, it's really, really warm, and then it cools down, and then it cools down to room temperature, never gets down to 0, because your pie wouldn't be at 0 degrees. So that one would be graph A. A trend line is a line of best fit. And you can see in example 10 how we kind of fit this line to the data. The scatter plot shows the relationship between the total amount of money collected at the concession stand and the total number of tickets sold at the movie theater. Based on this relationship, predict how much money will be collected at the concession stand when 150 tickets have been sold. Well, 150 would be about right here. Sorry, 20, 40, 60, 80, 120, 40, 150 would be halfway in between there. And so if we go over there, I would estimate at 150 tickets, people would spend about $750 on concessions. Number 11, sports team is selling wrapping paper rolls to raise money for new warm-ups. Create a scatter plot for the given information and have every 2 of these be 25. So that's going to be 25. It's going to be 50, 75, 100, 150, and that's as high as we need to go. And it looks like our values will have to be about 1,000. So I'm going to have these go up by 50, 50, 100, 50, 200, 50, 300, 50, 400, 500, 600, 700, 800, 900, and 1,000. So at 25 rolls, they raise $200. At 50 rolls, $300. 76 rolls, $501. At 103 rolls, $705. 115, $890, and at 150, they made $1,000. So I'm going to grab a ruler here, or a straight edge, and I'm just going to kind of try to do the line of best fit. This is not an exact science, but if this was the case at 175 rolls sold, we would probably be here, and I would guess that would be, my guess is that it would be about $1,200, and that is an estimate. We can do these trend lines on our graphing calculator, and this is pretty sweet. This is the price of stock over an 8-month period, and we're going to use the calculator to find the regression line. So you go to Stat, and we're going to do Edit, and we're going to enter in our first column 1, enter, 2, enter, 3, enter, 4, enter, 5, 6, 7, and 8. And then we have to arrow over to the top of that second column. You don't want to be up here in this L2 box. You want to be right below it. And you're going to do 32, enter, 35, enter, 37, enter, 41, enter, 46, enter, 50, enter, 54, enter, and 59, enter. So we just entered all of those numbers in, and now we need to go back to Stat, and now we're going to calculate, and we want the linear regression line. So come down here to number 4 and hit enter, and this gives us y equals ax plus b. A is 3.9, and B, I'm going to call it 26.7. So that is our linear regression line, and if we want to use that to predict the price of stock in the 12th month, we will do y equals 3.9 times 12 plus 26.7. And if we do 3.9 times 12 plus 26.7, we get 73.5. So that tells us in the 12th month we predict the price to be $73.50. And 13 is very similar. This time we are looking at dosage of a particular medicine. So we go to Stat right here in our calculator. Number 1 is Edit, and oops, I'm going to go over here. See, I arrowed up. This time we're going to do 90, 100, 110, 125, 140, 155, 170, 180, and 200. In the top of the second column, remember you don't want to be way to the top, you just want to be, you don't want the L2, you want the top of the next column. You do 20, 25, 30, 35, 40, 53, 60, 66, and 75. Then you go back to Stat, over 1 to calculate, and we want number 4, which is the linear regression line, and they give us ax plus b, which is 0.5, I guess I'll call it 0.51x plus a negative 26.8. And I would think the first decimal point would be fine. And there's our linear regression line. We're asking for two predictions, 240 pounds and 275 pounds. So we don't do 0.51 times 240, subtract a 26.8, and that would be a 95.6 milligrams. And then we do 0.51 times 275 minus 26.8, and a 275 pound person, I'm going to call it 113.5 milligrams.